Hello, welcome to Excel Class Hub. My name is Mr. Ken. I'm your physics teacher. I'm here to take you on the topic density. Density. What is density? A lot of students always misplace the meaning of density. Density has an English meaning and the physics meaning, but we're here to talk about the physics meaning. So I need you guys to come with me so I can explain to you what all about density. Now, what is density? Density is simply the ratio of mass to volume, and it has a symbol. This symbol is called rho. This symbol is called rho. Is a what? Ratio of mass to volume. Ratio of mass to volume. Now, what will be the unit of density? The numerator is the mass, the denominator is what? Volume. So that will be kilogram per meter cube or gram per cm cube. These two has relationship. How do we know their relationship? We can only get their relationship by using the density of water as our reference. By using the density of water as our reference. What is the density of water? The density of water is 1 gram per cm cube, which is equal to 1,000 kilogram per meter cube. So if I am given a density and it's in gram, I can easily convert to kilogram by using this measurement. 1 gram per cm cube, which is equal to 1,000 kilogram per meter cube. Are we together? Now, that is the real difference between density in physics and in English. So let's not mix them up. Right now, we're going to be going through some series. We're going to go through some series. The first thing is we have gotten the meaning of density. Now, how do we get the density of solids at the same time of liquids? Now, the first one we're going to look at is solid. Now, we have two kinds of solid. We have the definite solid and indefinite solid. Sometimes we say regular and irregular. What is a regular solid? A solid that has a measurable dimension. The dimensions can be measured. Examples of regular solid are cone, cylinder, cuboid. Those ones are regular solid. So how do we determine their density? We're going to look at that very soon. The next one is irregular solid. Irregular solids are solids that are shapeless. Example, a stone. A stone has no definite shape. You cannot give it a name. So that is an irregular solid. So we are also going to look at the way where how do we get the what? Density of irregular solid. So let's start with the density of regular solid. Irregular solid that has a shape. Now the first thing we will look for is the mass. Mass of a regular solid. Mass of a regular solid. What do we use to measure the mass of a solid? What we use is what we call the beam balance. Beam balance. We use beam balance to measure the mass of the regular solid. We use the beam balance to get the mass of the regular solid. Now, the volume of the regular solid, volume of a regular solid, how do we get that? Now, because it has a shape, the shape has a name, and it also has dimensions, so we can calculate easily the volume of that irregular solid. Example, let's look at cylinder. The volume of a cylinder is pi r square h. Pi r square h. If you talk about a cube, what will be the volume? That's L times L times L. All the sides are equal, which is equal to L cube. So this is how we get the volume of a regular solid. So when we get the mass and get the volume, the last one is to get the what? The density, which is what? Mass all over volume. So with this, we are able to get the what? The density of a regular solid. The density of a regular solid. Now let's quickly move to the other one, the density of irregular solid. The density of irregular solid. Now, like I told you earlier, that irregular solids are solids that don't have definite shape. They are shapeless. They don't have definite shape. So how do we get their density? Now we start with the mass. The same way we got the mass of irregular solid, the same way we're going to get the mass of irregular solid. So we're going to use what? The pin balance to get the mass of the what? Irregular solid. We're going to use the pin balance. Now, the major part of this irregular solid is the volume. Now, we have two ways of getting the volume of irregular solid. We have two ways of getting the volume. The first one is the use of measuring cylinder. Measuring cylinder. Measuring cylinder. And the second one is the use of Eureka can. We use these two methods to determine the volume of irregular solid. Now, I'm going to be taking them one after the other, and I'll explain how you can use them to determine the volume of irregular solid. Now, the first one, which is the measuring cylinder. Now, how do we use it? We get a measuring cylinder that is calibrated. We pour water into it up to a known level, and we indicate that level to be L1. Now, our irregular solid, probably we use a stone. We tie a rope to the stone and we lower it into the measuring cylinder carefully until it gets to the base of the measuring cylinder. Once it gets to the base, what do you observe? You will simply observe that the water level will increase. It will do what? Increase. Now, we're going to indicate that as L2. Now, from here, what will be the volume of the irregular solid? The volume of the irregular solid will be equal to the volume of water displaced when the irregular solid was dipped into the cylinder. The volume of water, the shaded portion there is the water displaced, the amount of water displaced. So the volume will be equal to the volume of water displaced by this irregular solid. So when we measure this, we say it will be L2 minus L1 will give us the volume of irregular solid. Will give us the volume of the irregular solid. So when we do this, we get the volume. Now they can ask you in exams, how can you measure the volume of a shapeless solid? You tell them we have two ways of doing it. You say that we use the measuring cylinder method or the Eureka method. Now, with the measuring cylinder, I believe we can do that right now. That one is very easy. You can see it on the board. Now, let's quickly go to the second one, which is the Eureka can. Eureka can, the use of the Eureka can. Eureka can is a special can. Special can, like I always tell my students, it looks like a kettle. But it's not like it's not a kettle, it looks like a kettle. Because it's in a funny, very funny shape. This is how it looks like. So what do we do with the Eureka can? We pour water into it. We pour water on the start to gush out from the nozzle. So once it starts gushing out, we allow it until the water stops dropping. Once it stops dropping, we get a measuring beaker. Put it under it. Now with our irregular solid tied to a rope, we lower it. Remember, our water level will be at the brim, close to the nozzle. Once we lower it into the Eureka can, what happens is that the water will overflow and pour into the measuring beaker. The water will overflow and pour into this measuring beaker. We will allow it to stay until the last drop enters. So the amount of volume of water here, the amount of water is equal to the volume of this irregular solid. The volume of water here in this beaker is equal to the volume of the irregular solid. I hope I've been able to explain this very well to us. So these are the two ways by which you can get the volume of an irregular solid. So once we finish getting their volume, the next thing or the last one is to get their density, which is always mass over volume. Mass over volume, which is the density of irregular solid. So quickly, let's look at one or two examples from our test Let's look at one or two examples from our test. Now, when you are given a physics question, you are meant to write down your parameters. First, understand the meaning of the question. What is the question actually asking? All right, let's listen to this question.
Okay. From the year 1983.
1983.
Question 8.
Question 8.
It says, if the relative density
of a
metal is 19, what will be the mass?
Relative density of a metal. Let us talk about relative density before we take that question. Let's talk about relative density before we take the question, so that we don't get too confused. So, relative density, we are coming back to this question. Relative density, what is relative density? Relative density has a lot of definitions. It has a lot of definitions. So, I am not going to be defining it, but I'm going to give you all the definitions that are necessary for relative density. So, the first one, relative density, R dot D is equal to mass of over mass of equal volume of water. It can also be weight of an object all over weight of equal volume of water. You can see relative density is density of a substance all over density of water. This third one, precisely, is the formula where we use to convert density to relative density and relative density to density. I want you to take note of this third formula. To convert density to relative density and relative density back to density. We have another one. Relative density is for height of object in liquid over my object relative density volume of liquid displaced by object over volume of water displaced by object, same object. These are the definitions of relative density. These are the definitions of relative density. So please, let's try and memorize these formulas. We can use any of them to define relative density. So with these formulas, we'll quickly look at the question we were looking at, 1983, question number 8.
Okay. So it says, if the relative density of a metal is 19, what will be the mass
of
20 centimeter cube of the metal when immersed in water?
What will be the mass of 20 cm cube when immersed in water? Now we're given the relative density as 19. We're looking for mass. And we know the what? The volume. We know the volume. So how do we get our mass? How do we get our mass? Now, this is how you interpret physics questions. You look at the parameters given to you. Now, I have mass, I have volume, I have relationship, I have relative density. Do I have a relationship between relative density and mass and volume? Is there any relationship? No. Now, I have a relationship that says density is equal to mass over volume. Okay, if I have this relationship, which relationship do I have with mass, volume, and relative density? I don't think I have any for now, but for density I have. I can say relative density is equal to density of objects, density of liquid over density of water. You can see that now. Relative density is like this particular formula number 3. Very important. Let's please take note of it. Very, very important. So from here we can get the density of the liquid. We can get the density of the liquid. Hope the question is very clear. Hope the question is clear. So let's go. We say relative density of liquid will be equal to density of liquid will be equal to relative density and multiplied by density of water. Our volume is cm cube. That means our density of water will be what? Will be equal to 1 gram per cm cube. So from here, density of the liquid will be equal to relative density 19 times 1, which will be 19 gram per cm cube. So the mass will now be, from this formula, mass will be equal to density multiplied by volume, which will be 19 times 20. 19 times 20, that will give us what? So we look at 19 times 20.
380.
Mass, that's grams. 380 grams. Is that clear? So that is a very good example to relative density. Let's look at another question there. Let's get rid of this. Let's go.
The same year, 1983.
1983, same year.
Question 31.
Question 31, you and me.
It says, what volume of alcohol?
What volume of alcohol? So we're looking for volume of alcohol. Alcohol. We're looking for the volume. What volume of alcohol?
With a density of
alcohol.
8.4.
8.4.
Exponential 2 kilogram. Wait for anything. We will have the same mass.
We have the same mass.
Yes. What volume of alcohol with a density of 8.4 exponential 2 kilogram will have the same mass as 4.2 meter cube of petrol.
This is volume of petrol.
Whose density is 7.2 exponential 2 kilogram.
7.2 times 10. Now, what will be the volume of alcohol? Volume of alcohol that will have the same mass as this volume of petrol. So what we're looking at is what? Mass of alcohol to be equal to mass of petrol. Mass of alcohol to be equal to mass of petrol. Are we together? So from this question now, we want to know the volume of this mass. Now, what is this density is what? Let's look at how we can manipulate. Density is mass over volume. Density is mass over volume. So when I make mass only to the formula, mass becomes what? Density times volume. Density times volume. Now, if you look at our question, we have density, we have volume of petrol, we have density of petrol, we have density of alcohol, but we're looking for volume. So look at this now. From here, we can now get alcohol. We'll say density of alcohol, let A stand for alcohol, volume of alcohol to be equal to, remember, mass must be equal. The volume of alcohol that will have equal mass as this volume of petrol. Density of petrol, volume of petrol. So what is the density of alcohol? Let's make VA solid to the formula, which is density of petrol, volume of petrol over density of alcohol. Alright, so what is the density of petrol? Density of petrol is 7.2 times 10 raised to the power 2 times, what is the volume of petrol? Volume of petrol is 4.2 all over density of alcohol, that's what? 8.4 times 10 raised to the power 2. So we're going to do this mass to get the volume of alcohol that will have the same mass as 4.2 meter cube of petrol. So what will be this answer? Can we all join in calculating this?
36,000.
36,000 meter cube. So it will be 3.6. We go 1, 2, 3, 4 times 10 raised to the power 4 meter cube in standard form. Is that clear? So we have dealt with density and we have looked at some tricky questions under relative density. Without wasting much time, let's move straight to Archimedes principle. Archimedes principle. Let's see what that man is telling us there. Archimedes principle. Archimedes principle. What does Archimedes principle state? Archimedes principle states that if a body is partially or totally immersed in a fluid. Now I'm going to break these questions down and have some points I'm going to bring out there. If a body is partially or totally immersed in a fluid, fluid can either be liquid or gas. Fluid can either be liquid or gas. If a body is partially or totally immersed in a fluid, it experiences an upthrust. Which is equal. Now, before I continue, what is upthrust? We have the first one, fluid. The second one is upthrust. So upthrust is also known as apparent. Apparent loss in weight. So if a body is partially or totally immersed in a fluid, it experiences an upthrust which is equal to the weight of liquid displaced. Let me now paraphrase it again so that it will make more sense. If a body is partially or completely immersed in a liquid or a gas, it experiences an apparent loss in weight, which is equal to the weight of liquid displaced or gas displaced. Is that clear? So, upthrust. What is upthrust? Upthrust is simply the weight loss of a liquid, of a body inside a fluid. The weight loss of a body inside a fluid. Upthrust has a symbol capital U. Capital U. Upthrust is a force. Upthrust is a force. So upthrust can also be defined as a force that acts on the body in a fluid in an upward direction. Always acts upward in an upward direction. So U is a symbol for what? Upthrust, which is equal to weight in air minus weight in liquid. Weight in air minus weight in liquid. That is what we call upthrust. Upthrust is a force. And what is force? What is mass time acceleration due to gravity? Remember, we did something with mass. We said mass is density times volume and g. What is this density? This density is what? Density of the liquid. And V is what? The volume of V is the volume of the object in the liquid. G is acceleration due to gravity. Acceleration due to gravity. We also have a lot of other formulas regarding to upthrust. Now let's go back to our relative density. We have formulas with upthrust and relative density. We can say relative density is also can be defined as upthrust in liquid all over upthrust in water. Relative density can be weight in air, weight of object in air, weight of object in air over upthrust. These are other formulas or definitions for relative density. These are other formulas and definitions for relative density. I want us to hold these formulas very well, hold them very well. We're going to look at some other things under this relative density, upthrust, and Archimedes principle. What are we going to look at? Now, I believe we all have this what we call well in our houses. For those of us that don't have it. Now, when you take a container, you throw it into the well, what happens? What happens? A lot of things goes on there, but we're going to look at three forces that act on that particular object. We're going to look at three forces. Now, when you're throwing it in, now when the body is going down, that's the first action we're going to look at. When the body is going down, the first one, when the body is going down, let me use the diagram to explain it. Now let's say this is the body going into the water. When you throw it into the water, this is the rope. You're going to exert the force that will bring this guy down. Now this is what we call the weight of this body. This is the force that will be pushing it down. Now, upthrust will act on it in an upward direction. Now, if we look at our equilibrium, we're going to say upward force is equal to what? Downward forces. My force is throwing it down. I'm pushing the container down. The weight is acting down, but upthrust is acting upward. So upthrust will be equal to weight plus force. The force responsible for throwing this thing down into the water. Now, when we are pulling it upward, up. When pulling the object up, the same diagram, our weight will always add that way, upward will always add that way. But this time around, we have a force that is going to tension this whole thing, calm down as tension. Now look at it now, this is weight is equal to the tension plus upward. The tension plus upward. This is another equation that we will need to hold because please let's remember these equations. They are very, very important. Now, from here, we're going to look at the law of flotation, what it's all about, and we'll also talk about the applications of Archimedes principle. We will now talk about that equipment used in measuring density. We're going to talk about that equipment. Now, in all what we're doing, you are not expected to cram anything. You are not expected to cram anything. You're just meant to listen and understand what we're doing. You're meant to listen and understand what we're doing. So let's look at the law of flotation. The law of flotation. What does that law state? The law of flotation. Law of flotation. For those of us that know how to swim, like we that can swim very well, we can swim even the ocean. We have the principle. I love physics because physics will give you all the principles you can use for life. Now, what does law of flotation state? What law of flotation states that a floating body displaces its own weight, of the liquid in which it floats. A floating body displaces its own weight of the liquid in which it what? Floats. Are we together? So what is simply telling us that for a body to float, we have two conditions that must be met. Number one is that the weight of the body must be equal to the what? Upthrust. The weight of the body must be equal to the what? Upthrust. Weight of the body, upthrust. Force, which is what? mg equals to what? Ng. What is our M? Density volume G equals to density volume G. G is acceleration due to gravity. What is this one? Let's say this is 1, this is 2, 2. Density 1 is what? Then remember, this is weight. Weight is in air. So density 1 is density of the object. Density of the object. V1 is what? Volume of the object. Density 2 is what? Density of the liquid where the object is going into. And V2 is the volume of the object that is immersed inside the liquid. So the volume of object in liquid. Volume of object in liquid. Remember, density 1 is the object, density of the object. Remember, the object is in air, which is for the weight. The object is in air. The density is density 1. Volume is the complete volume of the object that we're talking about. This second one is density 2 is the density of the liquid the object is going to enter. Now, V2 is the amount. If I stand inside water and the water is getting to my waist, so the volume V2 will be from my waist downward. From my waist upward, it's not affected. But from my waist downward. But if I go and I enter everything completely, that means the volume will be volume of everything, all my body. So let's note the difference between the volume here and the volume here. The density here is the density of the object. The density here is the density of the liquid. This is the volume, complete volume of the object. This is the volume of the object that is submerged inside the liquid. So let's note this. Let's note all this one. So law of flotation is telling us that the weight of the object must be equal to the upthrust. Must be equal to the upthrust. What do we call upthrust? Upthrust we say is apparent loss in weight. Apparent loss in weight. Now look at this. Upthrust, which is apparent loss in weight. W is what? This is actual weight. Actual weight. Now we have a third one. A third one which we call apparent weight. Apparent weight. Let me explain this. If I have this marker and this marker in air weighs 20 newtons, that is my actual weight. Actual weight is 20 newtons. If I put it inside water and the weight becomes 15 newtons, that is my apparent weight. Apparent weight is 15 newtons. So our up thrust, which is our what? Apparent loss. Apparent loss. Remember that will now be 20 minus 15, which is what? 5 newtons. Which will be 5 newtons. Do you understand? That will be equal to 5 newtons. So let's remember the difference between up thrust, actual weight, and apparent weight. Up thrust, apparent loss in weight. Apparent weight is the weight of that object inside the liquid. The weight of the object inside the liquid. Now, under this density, we have some applications like the ship, the iceberg, the balloon. We have, to some extent, we have the submarine. And we have our what we call the hydrometer. Hydrometer. Remember, it is different from hygrometer. Hygrometer. There are two different things. Hydrometer is the instrument we use for measuring density. Hygrometer is for relative humidity. What is the difference? Look at hydrometer has a D. Density start with D so that you remember. Hydrometer, D is there. Hygrometer, G, that's the difference here. So this one is for what? Measuring density, and this is for measuring relative humidity. Relative humidity. Now, the second condition of flotation is very simple. The second condition is that the density of the object that wants to float must be less than the density of the liquid in which it wants to float in. Density of the object must be less than the density of the liquid. That is the second condition. That is the second condition. Now, for the ship has a hollow. The ship has a hollow. Let me explain this very well. Now, we say density is equal to mass over volume. Now, you will notice that density is inversely proportional to volume. Inversely proportional to volume. So, if volume increases, density will what? Decrease. If density increases, volume will what? Increase. So, in the ship, if we create a vacuum in the ship, that means we are trying to do what? We are increasing the volume and decreasing the density. So, the density will be less than the density of the water in which the ship will float, so that the ship can float. Now, iceberg is made up of water. When you freeze water, it expands. That means the volume will increase. Once the volume increases, what happens to the density? It will decrease. So if you take a plastic cup or you take any cup, you take water from a container, you freeze that water. If you bring that water and drop it inside the same container where you took it, that ice block that is formed will float. Why is it floating? Because it has expanded. It has what? Expanded. So once the volume increases, the density will what? Decrease. It's a law. Once the volume increases, the density will what? Decrease. Now, there is what we call the hot air balloon. Hot air balloon. Hot air balloon, which we pour hot air inside a closure. We pour hot air, we channel hot air inside the closure. By doing so, the molecules of air inside there acquires this heat energy. They expand. Their energy is greater than the ones outside. Their volume is greater than the ones in the surrounding. So what happens? Their volume will increase and their density will what? Decrease. By so doing, they will float. By so doing, they will do what? They will float. So that is the applications of density. Please don't forget the hydrometer and the what? Hygrometer. So this is all about density. Now let's do a quick recap on what we just learned. We said density is mass over volume. Density is mass over volume. And the symbol for density is rho. The symbol for density is rho. Now, we said density, we looked at the density of regular and irregular solids. Regular solids are solids that have shape, that have dimensions that can be measured and calculated. But irregular cannot be measured. So we look for a way of getting their density by first of all getting the mass and also their volume. Now the mass of these solids are gotten by using the beam balance. Now there's what we call beam balance and there's what we call spring balance. There are two different things. Beam balance is used for measuring mass. Spring balance is for measuring weight. So we use that to get our mass. The volume, we use the volume for the regular is calculated, while the volume for the irregular, we use two different methods, the measuring cylinder method and the Eureka method together. After that, we looked at Archimedes principle, we looked at relative densities, we looked at different definitions for relative density, we looked at the law of flotation, and we looked at the applications and the equipment that is used for measuring density, which is called hydrometer. Remember, it's different from hygrometer, so that you don't mix them up. You don't mix them up. The D here will help you. Density is D, start with D. And there's a D here, which is different between hygrometer. Hygrometer has a G. So please let's remember this. So with all this, I believe I've been able to convince you and not to confuse you that density is what it is. God bless you as you always say. Thank you.